Alright, story time. So, about a year ago, I was in computer science class, just vibing, when suddenly, logic gates, tiny components were taking one or more binary inputs, like ones and zeros, and spit out a 1 or a 0, based on some rules. Simple enough, but for some reason, I got way into it. I mean, they are like the atoms of computing, and I thought, what if I could simulate these, like build digital Lego bricks and make stuff out of them? So I opened my IDE, cracked my knuckles, and started coding my very first logic gate simulator. On the surface, it actually worked. You could place gates, connect them, flick some inputs, and bam, get outputs. I even added saving and loading. Past me was thriving. But behind the scenes, it was a disaster. This is the code. I don't know what half of this does anymore. And the GUI, basic shapes, no labels, zero polish. If rectangles were a design trend, well then, I was the entire fashion industry. Anyways, now I'm rebuilding it from scratch, with a plan, with structure, and with actual clean code. Alright, let me walk you through the vision here. The new simulator needs to firstly look clean and minimal, well smooth, like buttery smooth, be easy to use, let you make your own gates, and eventually simulate an entire computer. Yes, video on that coming soon. But before we go full on build a CPU from scratch, let's start with the basics. Let's talk UI. I wanted something that felt good to look at, not just some white background with black boxes. So after messing around with like 30 different color palettes, I ended up with this one. It's subtle, clean, and kinda cozy. Now, to apply it, I wrote a full screen shader, because we are doing this with shaders. Basically, it calculates how far each pixel is from the center of the screen, and based on that, it blends between two shades of grey. It's simple, but it gives background some personality, makes it feel less flat. Then we add a grid, not just for looks, it helps when placing and aligning components, using the shift key by the way. And the cool part, the spacing adjusts when zooming in and out. It's subtle, but it makes everything feel grounded, like it's actually sitting on a digital workbench. Alright, time to light things up. Let's make a node. Think of it like a LED. At first, it's just a circle, but throw in some shader magic, blend some glow, and suddenly, boom, it feels active, clean, functional, and a little bit fancy. Now, we get into the core of the simulator, the logic gates. We start by creating a base class, and it is kind of like a template that every gate inherits from. So we've got AND, OR, NOT, and XOR gates. Each gate just overrides a function that defines its logic. Pretty straightforward, but the key here is making everything extendable, because later on, I want you to be able to build your own gates from scratch and plug them in like regular ones. But first, visuals. We are rendering them as rounded rectangles, because rounded rectangles, well, they're a future. I don't make the rules, but just look around you. Every modern UI uses them. From your phone, your apps, even your fridge probably has one. They're stuffed, friendly, and really satisfying to look at. So yeah, I'm fully committed. No more hard edges. Now, wires, the most chaotic part of any circuit. Here, a wire is just a class that holds a reference to two things. One, its input and its output, obviously. When the source updates, the signal travels down the wire and updates the target. And of course, the glow shader strikes again, because yes, the wire lights up when it's carrying a signal. Wiring stuff up feels really satisfying now. Alright, quick break from the visuals, let's talk functionality. Saving circuits, it's essential. Here's what I do. I analyze the current state of a circuit, sort the inputs, package every component with its own connections, and save it all to a JSON file. Loading? That's simple. You just read the file and recreate each component, reconnect everything exactly where it was, and boom, persistent circuits. You can build something, close the app, come back next week, and pick up right where you left off. Now, this is one of my favorite features. Let's just say you've built a really useful component, a 1-bit adder, a latch, anything. You can now bundle that entire mini circuit into a single custom gate. Just select it, name it, and it becomes its own component. Behind the scenes, it's still the same structure, it just hides the complexity and only shows inputs and outputs. It's like making your own integrated circuits, but way cooler. Alright, moment of truth. Let's test this baby out. But first, this video is brought to you by absolutely no one. It's just me here. So if you want to support this project, I've got two things for you. Firstly, a free but limited version of a simulator on my portfolio website, link in description, and also a full C++ version with all the features and lifetime updates for a small one-time payment. It generally helps a lot, and it's especially useful for students or anyone interested in building digital systems. So check it out, even just the free version helps a ton. Anyways, back to the video. Let's start simple, 1-bit adder. We just feed two inputs, connect it to XOR gates and AND gates, etc. And yep, we can try this out. Zero plus 0 gives you 0, 1 plus 0 and vice versa gives you 1, 1 plus 1, 1 and 0, and now for moment of truth, 1 plus 0 plus the carry gives you 1 and 1. Nice, it checks out. Now we can just stack 4 of them together and boom, you've got a 4-bit adder. Now, what about storage? Let's try building a D-latch. A couple of NAND gates here, we can just do some feedback loops here, and we can test it out. Oh wait, that's not quite good. That's a race condition. Turns out, updating every gate at once isn't the best idea. So instead, I randomized gate updates. Each one has a 75% chance of updating per frame. That way, everything eventually settles out without spiraling into chaos. Problem solved, and we've got a D-latch. Quick nerdy aside, but relevant. You might be wondering why I'm doing so much in shaders. The reason is twofold. Firstly, it offloads rendering to the GPU, which frees up the CPU to focus entirely on simulating logic. And secondly, it just makes everything feel snappier. No lag, no stutter, even with tons of components. Yeah, it makes me feel like the app's running on rocket fuel. Can't deny that, right? This is just the beginning. I'm working on building full ALU support, registers, RAM, and eventually a fully simulated CPU. I'm also planning on a puzzle-based website where you can solve logic challenges with circuits, kind of like LeetCode, but for hardware. And yes, I'm turning all of that into videos, so if that sounds cool, you know what to do. Well, go check out the simulator on my website, which is linked in the description, or comment and consider supporting the channel. Alright, before I go, here's a sneak peek of what I'm working on. Yeah, that's gonna be a whole of a video. Thanks for sticking around, and I see you in the next one.